Woohoo! We are live. This is Math 40 Elementary Algebra. And this section is all about using formulas to solve problems. And I know that nobody's favorite problems in math, well, very few people's favorite problems in math are word problems. But I think next to translations are the ones where you just get to, each word means something in math, and it can be very quick to get to your equation. The second best kind of word problem is the kind of word problem that is based on a formula, because you have a recipe for solving the word problem. However, it is a word problem. So, definitely go get your support animals, get your support Godzilla, get your support spider, get, whoever it is that, or whatever it is that makes you feel comfortable, and let's dig into some formula problems. So I have listed just a collection of different formulas. Some of these are from the book. Some of these are ones that I think are important. You'll notice I started out with a couple of economics formulas because I think they're really cool. And so the first thing is I just want to kind of look through to see what the heck is going on. These are some very powerful truths. So a formula is an equation that states a mathematical relationship between two or more variables. And when we put the equals between them, we mean these two things are equal, always. So let's start off with simple interest. So simple interest as opposed to compound interest is equal to the principal, that's the money you start with, times the interest rate times the time. You've probably done this in your head. You've probably worked out some of these. So this one may be one that you already kind of know. If not, I equals capital PRT is a really important one, and we'll be using this throughout math because it's a relatively simple formula. I mean, compared to some of the other ones that get a little more exciting down here. I want to point out, to be clear, and I know that this font is a little difficult, so let me specify, perhaps this makes it more obvious that this is a capital I. When you're working in mathematics, or really any field that uses formulas, make sure you're really careful about which letters are uppercase and which letters are lowercase. It isn't always obvious to the reader or the student why some things are capital and some things are lowercase. You can always ask me. I can generally give you a good sense of why someone has chosen to use a capital letter versus a lowercase. There are some rules. Capital letters tend to be things that either have already been named by another field or they're larger things. What do I mean by larger? Well, if we look down here, I've got the perimeter of a rectangle is 2 times the length plus 2 times the width. Notice the L and the W are both lowercase. The perimeter, which is a quantity made up of smaller things, the length and the width, gets to be capital. Same thing here. The area of a circle is pi times r squared. Notice r, which is the radius, is squared, but the area is capital while the radius is lowercase. So the area is made up by the radius times pi times another radius. So area gets to be capital, radius is lowercase. So the ingredients tend to be lowercase. The final product tends to be a capital, generally speaking. Now, when you look here, this is a formula we actually get from economics, that the profit, that's the money you get to keep, is the revenue, that's the money that the total that you make, the total money that someone gives to you minus your costs. That's the money you have to give back, you have to give away to someone else. That's the profit. Notice these are all capitals. This comes from economics, and they don't always follow our naming rules that we use in math. Here's one that I was only familiar with because of the book, but this is that the retail price equals the cost. So this is if you're going to sell something for retail, say if you have a flower shop, you would go and buy a bunch of flowers, that would be your cost, and then you would add an extra amount so that you could make some money. So that's called the markup. That's the markup to make extra money. Here we've got distance traveled. So the distance equals the rate, which we also call the speed, times time. Now, this one you've used if you've ever been on a long road trip and you're trying to figure out how many hours left. You might use a version of this when you say, okay, I take the total number of miles. If I have to go 100 miles and I'm driving 50 miles an hour, that'll take me 2 hours. If you've ever done that calculation, you've used this formula. If you've never done this calculation, that's okay. Math uses this formula all the time. And in fact, I would recommend of all of these, this one really should be memorized. I would really encourage you to. I always call it DIRT. D equals, that's an E-R-T. So D-E-R-T, DIRT. And that's how I remember this formula. Now, this one is actually really useful, but I think a lot of people forget which way it goes. Celsius, the temperature in Celsius, or what we used to call centigrade. So pretty much everywhere else in the world, except for the United States and one or two other countries, measures temperature in Celsius. And we in the United States use Fahrenheit. So we've got Fahrenheit minus 30, so you subtract 32, and then you multiply by this scaling, the 5/9. And the reason for this is because Fahrenheit is built on an observed scale. So once they decided how to measure a degree, they just tested and they saw, oh, okay, so water freezes at 32 and water boils at 212. And so that's the scale they used. It was observed. Celsius is part of the metric system, and they decided 212 and 32, these numbers are really hard to work with. What if we set freezing to be 0 and boiling to be 100? So that way it's a lot easier to calculate things. Because the scales are based on different perspectives, we have to have this conversion formula. You don't have to have this memorized. If I'm going to ask you to do this, I will give you this formula. This formula you don't have to have memorized. Let me put stars next to the ones you should have memorized. You should have the principal one memorized because this will come up a lot. So you really should have this memorized. Distance, rate, time, memorized. And then the formulas. The perimeter of a rectangle, when you're walking around a rectangle, if you start walking around a rectangle, you end up going through the width twice and the length twice, or you could call this the length and this is the width. Regardless, you get 4 sides, 2 lengths and 2 widths. So that should be memorized. And then this one, and if you've never used the area of a circle, I know this may look really bizarre, but just try to remember the saying, even if you're not sure what it actually means, just memorize area. The area of a circle is pi r squared. Pi r squared. It's like that. Pi is a beautiful number that was discovered many thousands of years ago. A couple. And it has to do with a special number property that circles have. It is the ratio of the circumference to the diameter of any circle. It's really awesome and wonderful. This is a geometric formula. You should have this memorized. It will come in handy. This one, I don't think needs to be memorized now, the volume of a cylinder. I just wanted to point out we can compare formulas. We can take a look at these two formulas and go, wait, the area of a circle is pi r squared. The volume of a cylinder, so this is a circle, and then this is a cylinder, which is basically, I always think of, it's kind of a silly thing to say, oh, that's beautiful, isn't it? Yeah, you can tell I almost went to art school. I think of it as a tall circle. And the thing about a cylinder is the additional dimension is height. And you'll notice that in the formula, pi r squared appears in both. It's just that you multiply times the height. That's because the volume of a cylinder, all the stuff that will fit inside, is basically just a bunch of circles stacked on top of each other. So how many circles do we have? We have h height worth of them. So I think these two formulas are really cool. You don't have to have this memorized yet, but if you know you're going to calculus, this one's going to come up a lot. We use this all the time in calculus because it's a really nice shape to study. It behaves really well, as opposed to other shapes that are really, unfortunately, difficult. Weirdly enough, spheres can be just, for calculus. So cylinders are best friends. Okay, so I would encourage you to memorize these. If you were, if you know that you're going into economics, you might want to, have these memorized. If you know you're going into physics or chemistry, this one's a good one. And again, math, this one's a good one. So I've just kind of given you a smattering of formulas. All the formulas in the homework and on the test, I will either be these 4 that I've asked you to memorize, or I will give you the formula. And the same thing with the homework. They'll either be on this list or they will give you the formula in the problem. Okay, shall we give this a start? I'm gonna have to move my support, and my support puppets are still here. I just have to give myself some room. I also have a calculator because some of these are gonna be things I can't necessarily easily do on paper in my head. So I'm going to use my calculator for some of these. Let me get this squished over there. There we go. Okay, let's get started. I know word problems stress everyone out. Remember, Godzilla's here. Godzilla loves you. Believe it or not, math loves you. It's just, it's kind of a hard love, but it does love you. So Godzilla's right here. You can do it, says Godzilla. Okay. Find the markup on a dozen roses if a florist buys them wholesale for $12.95 and sells them for $47.50. This is obviously describing Valentine's Day or Mother's Day. These are the big florist holidays when they can really sell because everyone wants to buy roses, right? So first thing I'm going to do, if I know this is going to be a formula problem, I look for keywords over here that would help tell me which one of the formulas we have, and I see the word markup, and I notice here's markup. So I'm pretty sure it's this formula. So the very first thing I'm going to do is I'm going to write out the formula over here. A lot of times, if you're handwriting a test, having the correct formula gets you a couple points right off the bat. Even if that's as far as you can go, you get partial credit. So we got the partial credit. Now I'm going to read it again. Find the markup. Okay, so the markup is the M. There's the markup on a dozen roses. Now, I have a number 12 here, so I'm thinking maybe 12 is going to be in the problem, but I'm not sure. If a florist buys them wholesale, now wholesale is the price that you pay if you are the florist. You pay wholesale, you pay less directly to the farmers or whoever the group of people selling the flowers, the flower market. And so that's the price you pay, $12.95. So I think that's our cost here, and sells them for $47.50. I believe that's the retail price. Okay, so let's look through here. We got a retail price right here, and I'm pretty sure that's that. And then our cost, wholesale cost, is right there. And then I'm asked to find the markup. Now I do notice as I'm reading through this number, the dozen roses, is actually not important. This is a red herring. It's additional information that we're just not going to use. The dozen roses, it doesn't ask us what's the markup for each rose. It's just the dozen roses all together. So I don't think we're going to need to use that 12. So I'm going to go ahead and identify. I think the retail price, the R, is the $47.50. The cost, and then I'm going to write here wholesale, so you can remember that. If you see the word wholesale, that's usually the cost. That's $12.95. And then I'm going to remind myself that it says find the markup. And so I'm going to say, what's the markup? So this is my style for solving problems. This has been the same style I've used since I was in school. And the way that I do it is I get my equation, and then I write out each of the variables and see if I know a value for it. And then I just keep going till there's only one I don't know. And so if this style doesn't work for you, if you've got a different style, go for it. You don't feel fixed to my style. This is just how I do it. So I'm going to rewrite the formula because, again, I don't like to have to look very far up and then look down and look up and look down. I like to keep my information together. So I tend to rewrite things a lot for myself, which is fine. 4750, 4750. Remember when we start using math instead of English, we're going to take out the units. So I'm not going to write the dollar sign in. My cost is $12.95. And my markup is just M. And I'm going to use the variable I'm given, so I don't have to declare variables or anything. I'm just going to say, what's M? Now, I've got an equation. As soon as you've got an equation, woohoo, an equation. I would recommend you stop reading the problem. Maybe read it one more time to make sure you got it, but don't spiral. It's really easy to get stuck up here. Don't get stuck up here. Come down here. We've got an equation. Let's solve this equation. Even if we were headed in the wrong direction, at the very least, we'll have something. We'll be able to get a value and see if it seems to make sense. So I want to solve for M. And so I think what I'm going to do, because this is adding $12.95, what am I going to do? You got it. I'm going to subtract $12.95 from both sides. And I'll remind you, and I'm going to keep reminding you, if you put your pen or pencil on the equal sign, you put the pen or pencil, you should see $112.95 on each side. If they're both on one side, then you've done it wrong. Make sure one on each side. Okay, over here, this cancels out, and I just have the M. And over here, this is some serious subtraction. I know, I should be encouraging you to do subtraction, but I don't trust my brain again today. Oops. Ring light, ring light, ring light. There we go. So 34.55, which I'm sure we could do. You guys could probably do that subtraction, but you're allowed to use a calculator, so I'm making use of technology. So it looks like I'm done. My markup was equal to, and then remember the units, we're talking about dollars. So it's 34.55. And remember that for my class, I don't require sentences, but a lot of teachers do. So you would need to say the markup is $34.55, something like that. Okay, and there we go. Hopefully that didn't feel too stressful. Shall we try another one? Yes, let's try another one. Yay. Okay. Move this down a little bit. Okay, this has got a lot of numbers. We start off with a number, right? We're always looking for numbers, but they won't always fit into the equation. So the first thing I'm going to do is read the problem. 3 years after opening an account that paid simple interest, interest. I'm thinking interest, but let's keep reading. Of 6.45% annually, a depositor, the person who deposits, withdrew the $3,483 in interest earned. Ugh, this is some serious economic language here. How much money was left in the account? Okay. Given that I said the word interest, said the word simple interest, and over here, I didn't write it in, but this is simple interest. And later on, depending on what math you take, you get to see what other kinds of interests there are. There's also something called compound interest, which is also kind of a complex interest if you're looking at it from a math perspective. Okay, so I think it's simple interest. So I'm going to go with this formula. Oops, there we go. My interest equals principal times rate times time. Okay, there's my formula. Now I'm going to read through and I'm going to see what I know and what I don't know. And in fact, what I'm going to do is write these out. Okay. So I'm looking for interest. I'm looking for principal, which is the money you start with. the interest rate, and the time. Okay, so right off the bat, 3 years after opening. Ooh, 3 years after opening. 3 years. Look at me. I got 3 years. So this is my T. So I've got 3 years. Now, make sure it's in years. If it's in months or days, you're going to have to convert. This formula works for, well, we'll talk. Let me hold that thought. I was about to say something profound, but let me say it in just a second so I can actually point to something. Okay, 3 years after opening an account that paid simple interest of 6.45% annually. Interest rate is R. 6.45% annually. Annually means years. These agree. That's really important. With a lot of formulas, you have to keep your I need to not do this. You need to keep your units consistent. So we've got annually, we've got years, we're good. If this were annually and this were months, we'd have to convert something. If this were monthly and this were years, they don't agree. So these two have to agree. And then the second thing is, remember that with interest, with percents, we just practiced this in the last section. With percents, you've got to convert to a decimal to use it in a formula or in algebra. So remember, percents are like the dollars. Sorry, percents are like the cents. Sorry, this is new for me. Percents are the cents, and I need to convert to dollars. So this is going to be 0.0645. That's my interest rate as a decimal. No percent sign anymore. Okay, a depositor withdrew. Ooh, I didn't underline, so let me do this. Simple interest. There's the R. Okay. A depositor withdrew the $3,483 in interest earned. Now, here's the thing. At this point, I only have two of these variables that I don't have a value for. So I got a 50-50 chance of picking the right one. Now, this one's called interest, and this one's called principal. And if it says it's $3,483 in interest earned, I'm pretty sure this is going to be here. $3,483. And then the principal seems to be the one I don't know. So let me double check. How much money was left in the account? So now this is a little bit weird. So let me underline this, and let me talk about what's going on. So what's going on is, in general, if you are looking to make an investment and you want to do a very simple one, you can put money in the bank. You just put money in like a savings account or maybe a money market account. And if you spend some of the principal, slowly over time, you will earn less and less money. If you put a certain amount of money in, and then when it develops interest, if you just take the interest away, you've still got the original amount. And then every year it makes interest, and you spend the interest, and then you start the next year with the original amount. And so that way it's kind of like if you've ever had like herbs growing, if you have an herb growing and it grows, if you chop down the whole thing and you use it to cook, then you have no herbs. There's just nothing. But if you wait for the herbs to grow leaves and you take some of the leaves, then over time it'll grow more leaves. You can take just the leaves, and then it can keep growing. So this is what's happening. So what they've done is they put the money in, it grew some interest, they took the interest, and then they want to know what's left. So what's left in the account was what we started with, the principal. And that's the one we're trying to figure out. So that's our question mark. Okay, so I'm going to write the formula again. And I'm going to go ahead and fill in the blanks. I've got 3,483 P, I'm going to leave as P because we don't know what it is. R is 0.0645. Now, I might choose, instead of using multiplication, I may put parentheses in just because all those little dots are going to confuse my eyes. And if you have eyes that are as easily confused as mine, then maybe you want to use parentheses. If it doesn't confuse you at all, use multiplication. Again, this you get to choose. And then the last one is I'm multiplying times 3 years. So notice if I put in parentheses, I don't have to write the multiplication signs. So I got some choices. There are a couple different ways to approach it. This is the equation. Woohoo! Woohoo! And I could do a couple things. What I think I'm going to do is I think I'm going to multiply these two constants together as a way to simplify the right-hand side. Remember, if I have 3 things multiplied together, I can choose to multiply any 2 of them. So I'm going to do that. So I've got 0.0645. Oops, but you can't see that. There we go. 0.0645 times 3 equals. And so this becomes 3,483 equals P times point, I can't quite read it even though you can, 1935. Okay, now we come down to it. This is what we want. We want to get the principal out. It's multiplied times this amount. How do I get P by itself? What do I do to solve the equation? I want to isolate P. You got it. Woohoo! I'm going to go ahead and divide both sides, 1935, by this 0.1935, 0.1935. And then over here, where's my handy dandy red pen? These two cancel, and all I have left over here is P. Now let me look at the left side. I've got 3483 divided by 0.1935. And oh my goodness, that is so cool. It turned out exact. It's 18,000. So what does that mean? Well, what that means is I started with $18,000. So my principal was the amount I was left with equals, and again, remember for me, the most important thing is you have to put in the units. So the amount left in the account, the amount I was left with was $18,000. Woohoo! Nicely done. Nicely done. We got through another one. Yay! So here's the thing. Let's see. I'm at 28 minutes and I've still got 2 more problems to do. So I think this is going to be a multi-part chapter section because word problems just take a long time. So I'm going to go ahead and break the video now. Well, hopefully I won't break it, but I'll pause it. And then we'll come back and we'll do 2 more problems. And then there's another section in this chapter that we will go over. So this is going to probably be 3 or 4 sections of videos. So I will see you in the very next one. Congratulations on making it through 2 word problems. Woohoo! Woohoo! Math on.